We are going to keep rolling from that last video with our next big topic, loops. One of those things that it's hard to write a real program that has any value without the ability to write a loop. And a loop is just what it sounds like. It's a way to do the same thing over and over. So the syntax doesn't work quite like this. We don't literally write the word loop, but we do literally write a colon. Just like our if statements, we indent a block of code, and the loop will run this code until it is told to stop. And how do we know where that block of code, or how do we know what runs? Well, the indentation tells us that. It doesn't matter what is here, but whatever is at the same level as that colon is not part of the block. So, right, loop, keep going, right, run these same lines of code. This is where computers shine, right? We joked a couple videos ago about how computers are good at math, right? Python excels at math. Computers are good at doing the same thing over and over with perfect precision and accuracy, really fast, and never get fatigued, right? That is something humans are not good at. If machines take over, that'll be why, because they can do the same like repetitive task with incredible precision and perfect precision and accuracy, and never get tired of it. Okay, let's have an example quick. Let's say what's a repetitive task that you do often? Let's put up here dirty dishes. Okay, you've got a bunch of dirty dishes sitting right here. You have a sink full of soapy water. You have another sink where you're going to dry them, and then you have a place where you're going to set them at the end. The process is pretty straightforward, right? Task 1, grab a dish. Step 2, wash/scrub the dish. 3, dry the dish. Step 4, set aside, and then repeat. Okay? That's a loop, right? You have a collection of something, right? Or you have a reason to keep going. This is the block of code, right? The lines that we're going to run. Keep going until, right? Repeat until we've run out of dishes. Each time through, the loop is a tiny bit different. Now there are two different types of loops you can write, but each time through, the dish is a little bit different. Maybe it was a fork last time, maybe it's a plate this time, maybe it's a cup, but the process, you're gonna operate on that different thing a little bit different each time. So we keep going until we run out of dishes, or there could be something else like a visitor shows up, or the water, like we use up the water, or it runs out of soapiness or something like that. So there's a couple different reasons why you might have to stop, but ideally, right, you keep going until you run out of dishes. Okay, so there are two sort of syntaxes, like I said, and we'll code these out here in just a minute. There's what is called a while loop, and a while loop will be while this thing is true code. Okay, run this code. In our case, right, in our example, the X would be while there's still another dish, grab the next one, grab the next one, grab the next one. Oh, that's not true anymore. There are no more dishes. That means our loop is done. And it will look the same now, though it's, we'll talk about the difference later. It's called a for loop, where we'll say for X in Y. So however many of these do this, right? So run the code, let's say 1 to 10 times. So run this loop for the first 10 dishes. Or maybe it's for each dish in dirty dishes, right? We've already figured out how many dirty dishes there are. Keep going, and you can just keep count, right? Keep track of how many there are. They serve different purposes. You use them in different situations. It'll become clear. Let's go code it out. But you've got at least an understanding of how this process works. Let's go code.